Hello and welcome to Peak Flicks. My name is Mr. Lepore, and I'll be working alongside you all throughout the summer on a variety of math skills. Each day we'll be working on a small fluency component, and right after that we'll take a look at a variety of different topics throughout the fourth grade math curriculum that we think will be beneficial to you to sharpen up on in order to prepare for everything that's to come. In addition, we're going to make sure to remind you that every day you need to make sure that your top right circle in our reflex math program is fully green inside and out. All right, guys, so for our fluency today, let's just go ahead and recap our 2's and 3's times table and quiz yourself to see what you know. As usual, I'll give you guys about a second or two to think of the answer yourself and call it out before I say it myself. 3 times 10 is 30. 2 times 5 is 10. 3 times 3 is 9. 4 times 2 is 8. 3 times 6 is 18. 8 times 2, 16. 7 times 3, 21. 2 times 7, 14. 9 times 3, 27. 9 times 2, 18. 3 times 8, 24. Hopefully you guys did well there. Had a nice little recap. On our next lesson, you're looking at it, we'll be doing our FORNS times table. Make sure that when we're done here today, as always, you are logging on to Reflex through your Clever account and getting all your work done until your top right circle is fully green inside and out. All right, guys, let's get ready for our third lesson here today. Today, we're going to be reviewing the various different ways that you can represent numbers. Okay, so we also call them number forms. So let's take a look at our objectives. Students will be able to read and write multi-digit numbers using base 10 numerals, numbers names, and expanded form. Students will be able to read and write multi-digit numbers using base 10 numerals, number names, and expanded form by inputting numbers properly into a place value chart and representing them in different ways. So let's review some of these number forms. You are going to be familiar with this from your work in previous grades. So our first form is standard form. That's how we're used to seeing numbers. We see them strictly as numbers. Okay. We also have expanded form. So expanded form is when you take the standard form, but you represent each number by its value. So for example, the 5 in the hundreds place has a value of 500. The 2 in the tens place has a value of 20. And the 3 in the ones place has a value of 3. And it almost looks like you're putting this into an addition equation here. So standard form and expanded form. The last way we're going to focus on is word form. Okay? The easiest way that I teach this is you write it how you say it. So we would say 523, and you write it how you say it. 523. Let's take a look at our first problem here, and let's get ready to learn. Quickly, our place value chart. This will come in handy again, and this will allow us to be very successful with turning our standard form into various different forms. So, on the place value chart below, label the units and represent the number 90,523. So, as usual, I got my ones, I got my tens, I have my hundreds, I have my thousands, good job. I got my T dash TH for the 10,000s place. I have my 100,000s place, so now I'm going to do H dash TH. And lastly, I have the millions place. Boom. Now I have to place and represent 90,523. So there's a few different ways to do this. But I know that this number right here, the 3, belongs in the ones place. So I'm actually going to start from the back. I have 3 ones. It looks to me in the standard form version of this number up here. I have 2 tens, 5 hundreds, no thousands, and 9 10,000s. 1, 2, 3, comma. All right. So now they're tasking us and asking us to write the number in word form. So if we could remember all the way back to just a few slides ago, we went over word form, and my number one trick is to write it how you say it. So here I see 90,000. So anytime I see a comma between the thousands and the hundreds place, when I'm reading a number, that comma to me says thousands. So 90,523. So below, I have typed 90,523, right? You simply write it how you say it, right? Okay. Lastly here, we now have to represent the number using expanded form. If we could remember back to expanded form, that is where we find each digit's value and put it into what looks like an addition equation. If we were to add it all together, we would still get our original number in standard form. So whenever I work with expanded form, I like to always start in the greatest place that's visible. This is the 10,000s place, right? So I know that 9 10,000s have a value of 90,000. Get my addition sign going. I also know that when I have a 0 in any place, I do not have to represent that in expanded form. So I've showed my 9 10,000s. I can skip over the thousands because 0 has a value of nothing, right? A value is 0. So I can go right to the hundreds place. If I have a 5 in the hundreds place, I know that value is 500. Get my addition sign ready. Go right to the tens place. I know that my 2 in the tens place has a value of 20. And get my last addition symbol here ready because I know I have a 3 in the ones place, and any number in the ones place has a value that is itself. So this is 3. So if we take a look at what I've done here, again, using my knowledge of the place value chart, right? I was able to input the number properly, right? Standard form up here. I was able to represent it using standard form in my place value chart. After that, I was able to write it properly. You write it how you say it. 90,523, right? An expanded form, that's when you take the value of each number that's represented in the total number and you show its value almost in an addition sentence here. So my 9 10,000s is 90,000. When you don't have a value, you do not need to represent it. So I skip over the thousands, 500, 20, and 3, and I've put it into a nice little equation right there. So let's take a look at a very similar problem, and one that I think we can maybe try on our own and also follow along with me. So here is our next problem of the day. I see a lot of similarities with this problem here. So it says on the place value chart below, label the units and represent 905,203. All right, so let's get to labeling our place value chart. You should be knowing this by now. Ones, you guys could say this out loud to yourselves. So there we go. From the ones to the tens to the hundreds to the thousands to the 10,000s to the 100,000 to the millions. All right, this should be almost second nature now. This is our third straight lesson and a handful of problems where we're using our place value chart to help guide us. So I see my numbers here in standard form. Now, just to repeat in the place value chart and make sure I do it accurately, I always start in the ones place. So I have a 3 in the ones place, a 0 in the tens place, a 2 in the hundreds place, a 5 in the thousands place, 0 in the 10,000s place, and a 9 in the 100,000s place. 1, 2, 3, comma. So if I read this problem out loud, here's how I do it. I read 905, and what does this say? This says to me 1,203. So I always use the comma to kind of help me break up my standard form numbers when I say them properly. And then that also helps me in word form because, as I say, you write it how you say it. So now that I have written out my number in word form properly, let's take a close look at it. 905,203. Notice how there's no ands there. I don't say 905,203. There are no ands whenever we are transferring from standard form to word form. And whenever we say the number, we should be saying it without the word and also. So again, it would read 905,203. That is my standard form to word form. Lastly, I'm now going to take things into expanded form. All right, expanded form is when we find the value of each of the digits and we represent it in what looks like a larger addition sentence. If we were to add them all together, we would again get 905,203. So whenever I do this, I always start in the greatest place I have a number. That's the 100,000s place. So 900,000s can be represented as 900,000, right? And I have a 0 in the 10,000s place. So do I have to represent 0 10,000s? No, I don't. I don't have to do that. So I'm going to skip over the 10,000s, go right to the thousands place. Here I got myself 5,000. So I'm going to represent that as its value, which is 5,000. And next I'm going to go over to the hundreds place. In the hundreds place, I have 200s. So how do I represent that in expanded form? Well, 200s have a value of 200. Now for the second time in this standard form number, I notice I have a 0. I had a 0 in the 10,000s place and a 0 in the tens place. For the last time, we do not have to represent any place that has a value of 0 in expanded form. So I got to jump to the ones place and I have myself 3, which has a value of 3, right? Anything in the ones place has a value of the number itself. So 905,203. I did that in word form. I wrote it just how I just said it. And then in expanded form, I went and I took 900,000s, 5,000s, 200s, and 3 ones and represented it using expanded form. So that was just a little work today, right? With numbers in their various forms. There's different ways to represent numbers, and you got a little review and another look at how to do that properly. Also, make sure that you're getting onto your Reflex Math account that you could log in through Clever every single day when we're done with our math work here. You'll know you're done when the top right corner of your screen shows that your circle is fully green. Enjoy.